Are we live now?
I think we are.
Well, we tried something fancy there. We had a really nice video that was done by our designer that was going to kick off. But unfortunately, when we hit the go button, it muted us and didn't show the video. So if you take a moment, close your eyes, think of a really cool VictoriaMetrics logo popping out and introducing us. So
We'll everyone that works on the production team for this.
Yeah. Oh, we're gone. Yeah. So everyone, welcome to VictoriaMetrics Tech Talks. My name is Mark Sherwood. We're joined by Matthias. This is our third episode in this series, and we're continuing our journey looking into logging. Today's topic is from chaos to clarity, mastering your logs with Victorialogs. And really what we're excited to share today is just that continued journey of our first is where we showed how to just simply deploy it, get some data into it. We looked at how to visualize some of that data. Now we're really looking at how to optimize, to enrich, to really get actionable insights out of your data in the easiest way. So, Matthias, do you want to introduce yourself?
Yep. I'm Matthias Palmersheim, and I work as a solutions engineer at VictoriaMetrics, and I have some fun horror stories about logs I'd like to share while we're waiting. So back at a previous role, I was responsible for setting up a logging solution, and I didn't know what SD parameters were in syslog, which is a way of adding structured metadata to syslog. And so instead of just telling the collector I was using to say, hey, this is structured metadata, pull that apart for me, I actually was writing my own query to parse the logs at query time, which is really expensive. Spoiler for later in the stream. But we also had, like every time you wanted to visualize those logs, we had to copy paste that mile long statement to parse apart. I think it was like BPXD and vSphere. So it had like 5 or 6 SD parameters and then the actual log message. And so that was a fun time.
Yeah, well, a learning experience, but hopefully you got some good lessons out of that. And my logging background as well, I've got some PTSD. I mean, experience in logging. I've, from a work capacity, worked with Elastic and Splunk, and also in the earlier days, set up my own very bad logging systems, and yeah. Found out the issues that I could cause. So one of the things we're curious is to the audience today who's joining us or maybe even watching down the road. We'd love to hear what your level of experience is with logging. Is it something you're tried and true? You're just an expert at it? Is it something you're getting into? Or maybe is your idea of logging what I've seen in a lot in the past, where everything is logged on disparate machines and somebody's SSHing around to try to grab all that information? Just curious if what your experience level is. If you could throw that into the chat, that would be awesome.
And one other thing I'd like to see in the chat too is what tools or what your log pipeline looks like right now. That's something I'm really curious about, and we're going to go over some common tools for setting up an ingest pipeline for logs during the stream.
Yeah, cool. So I think we can just keep on going as well, Matthias. Maybe we want to get into a little bit about Victorialogs from your position. We know where it is, but just like hop into this. What is optimizing data coming in for? What are we trying to solve for?
Yeah, so Victorialogs, it's a log management system that you can spin up with a single binary and some command line arguments, so there's no complex configuration files. And the way the data model for it works is that it's kind of broken up into 4 parts. So there's a timestamp field, pretty self-explanatory when the log happened. The message field, which is the actual message content of the log. And then there's stream fields and other fields. So stream fields route data to a specific part on disk. And then other fields is where the rest of the metadata kind of gets stored. And last time when we started, we were just kind of shoving everything into the message field. And then at the end, we got to where we could pull it apart with an extract pipe. And that's okay. And it's still pretty performant, but we can do much better. So what we're going to work on today is trying to take the information from that log, use some really awesome open source tools, and then keep the message looking the same, but get metadata into other fields. So then when we query, we have simpler, shorter queries, and then we also get more performant queries, because instead of having to take everything off of disk, read apart the message, pull it apart, and then look for a field that we generate. We're just saying, hey, I know this is the field I'm looking for. Do your query on that specific field.
Yeah, perfect. I heard somebody or read online in the last couple of weeks, somebody was describing logging sort of like your library, and it's got all the information, but it's if you don't have your indexing and all of those books are just on the floor, you're in big trouble. And without really optimizing and enriching that data, it sort of is like that, isn't it? You have everything. It's just it takes a lot longer to search and to know where to look to find the answers. So
yeah. And another thing we're going to get into too is that there's some information that the application doesn't even know about. And so we could add that to the log before it hits Victorialogs, like what team's responsible for the log or other metadata.
You have somebody trying to escape from your room.
Yeah, that's Moxie, our chaos engineer.
Perfect. So if we lose the microphones, it means it's chewed through your wireless dongle. Awesome. So I've been hearing more talk about the 4 V's of logging. Is that what are the 4 V's? Is it a good time to jump into that, or where?
Yeah. So I have to keep this on my notes to make sure I get it correct too. So the 4 V's are volume, velocity, variety, and veracity. So volume's the first one, which is just the sheer number of logs or the amount of logs being sent to the system. And then velocity is how often and how they're appearing. So there are some things like a public facing web application where there might be some peaks and troughs, but overall there's usually some steady load hitting the application. But then there's other things like CI jobs where during 9 to 5, there might be a ton of different CI jobs running. And then outside of working hours, it's a ghost town. So different applications are obviously going to have different velocity of logs, whether that's time of day, whether that's use case, depends. And then variety is the shape and the size. So some companies, like if you're in a newer company, everything might be in a Kubernetes cluster that's all structured logs. So everything's wrapped in JSON, all nice and pretty. And then there's other companies that could have had a bunch of different mergers and acquisitions that on paper, I like to use this example a lot, but on paper, it's one company. But if you look at their IT, you could definitely tell it's like 4 companies in a trench coat pretending to be one. And so some of those companies could be very modern, have everything parsed and labeled properly, and then an ERP system from like the 1980s that barely supports this log. And then veracity is how complete and accurate the data is. So is it labeled correctly? Are the right parties, like, does it have an environment label? Does it have a team owner label and some of that other metadata as well? And are the logs accurate? So sometimes what happens is that the collector will send the logs to the logging system with the timestamp that it sent the log at, not the timestamp of the log. So there's some other accuracy issues we can run into as well.
Okay, cool. Looking forward to seeing how we address these particular items that we do. So, yeah.
So brief recap of where we left off last time. Last time we were using Proxmox Backup Manager as our test application. Again, I thought about using my firewall because that's a really fun case for parsing, because the CSV file is like 20 different random fields. And speaking of a long, gnarly query to pull that apart every time, that doesn't sound very fun. But I didn't want to broadcast my IP address to the whole wide world to get DDoSed. So we're going to use Proxmox Backup Server for the application. And that has some structured or the logs are structured, but it's not like a machine readable format. And so at query time, we were having to use an extract pipe and pull everything apart. And so in this stream, we're going to front load that effort onto a collector. So right here, let me pull up my screen. So here we can see our logs from last time where we just had the app name PBS and everything's pulled apart in the message right here. let me zoom in a bit before chat yells at me. So here we have all the we have the message field here, and the way that's being ingested is using syslog. So before we were just sending that straight to our Victorialogs host without using a collector. So we're going to pick 3 different collectors today. We're going to use Vector, which is an open source collector released by Datadog. We're going to use the OpenTelemetry collector, which is a vendor neutral way of sending all sorts of different types of telemetry. And we're going to use Telegraf because that's the one I'm super comfortable and familiar with. So what this is going to look like is all the collectors kind of have the same structure. They have an input, transforms, and then an output. And to get them to the different collectors, we're going to spin up a syslog server locally. So first, we're going to take a look at the OpenTelemetry collector. So we're going to set that as our syslog target. We're going to restart the syslog service. Restart our syslog. And then we're going to go over to our Victorialog server where we have the OpenTelemetry collector contrib installed. The reason why we're using contrib is contrib has hundreds of input plugins available, and the OTel collector proper is pretty stripped down, which has the benefit of being more stable, but if you need certain features, it can be really tricky. Then Etsy OTel collector contrib. And then, Mark, is my screen legible?
Yeah, I'm able to see it quite clearly. Sorry.
Perfect. So OpenTelemetry calls the inputs that it has receivers. So what we're saying here is use the Prometheus receiver to grab everything from the OTel collector itself. We're going to use the host metrics plugin just so we can see the resource usage that that we have on the system. And then we are going to use the syslog input. So what that's going to do is open up port 8000 as a syslog server that receives RFC 5424, which is fancy syslog, not old school syslog. That's how I remember it. And those are all the inputs. And then the processor section here, we're going to use batch, which is recommended by OpenTelemetry for all the plugins. It's going to smooth out getting data to the correct destination. And then we have this transform plugin here. So what transform does is it can either completely change or add data to syslog, to a given receiver. So here we're saying ignore any errors, and you can OpenTelemetry is particular about which things happens to which signal, and so is Vector. So we have to say to our logs, we want to do these transforms. So we're going to say if in the body we see PBS anywhere in the log message, so we're not trying to apply a grok filter or any other processing to irrelevant messages. And then we are going to use the merge maps function, which takes a few arguments. So in the attributes, we're going to add to the attributes the results of this grok pattern. So grok was, I believe it was developed by Elastic to kind of be sort of a regular expression on easy mode. I'm pretty sure we're all familiar with the joke about I had a bug, I used a regular expression, and now I have 2 bugs.
Yeah, I think with regular expression, easy mode still isn't that easy for many.
So here, we're going to use this pattern. Kind of looks familiar. It's just some different syntactic sugar. Instead of using the pattern, we're using grok. So we're going to add all of these fields to the log. And then once we've performed that transform, we are going to go to the exporters section. And exporters is what OpenTelemetry calls an output.
Real quick, Matthias, on that, building the statements in sort of that batch processing there, I guess a very important first step is to understand your logs and what you're trying to get in, right? Because it seems like this is, you're acutely aware after while building this statement of what you want to bring in. Is there anything that you can add to how to get to the point when you're looking at just the raw logs of how to properly build these statements? Like where do you find the value in it? Or is that just something that's inherent and specific to each particular application?
So each application is going to be a bit different. And to figure that out, I'll go to the log source itself, ideally, or in a lower environment, I will pull it apart using the extract pipe or unpack JSON like we did last week. So using the extract pipe is super handy if an application changes or you haven't given it the time and attention to set up an ingest pipeline specific to that application. And then ideally, after you have a rough idea of what's going on, you could either use Grok or if it's structured logs to say, hey, this is the structure of the logs, shove all this in other fields. After you see what the log looks like itself. So that's the process I go through is I'll look at the log either in Victorialogs or on disk or from the output of like var log messages or something like that, and then go from there and figure out what's the best way to pull it apart.
Okay, thanks.
While we're on the subject of figuring out how to pull these apart, one problem I did run into with OpenTelemetry was the docs were pretty scattered. So I found this function inside of a pull request for adding Grok support to OTel. It wasn't laid out particularly in the docs, and something that was nice about Vector and Telegraf was either in GitHub or in the vendor docs, they had like every parameter pretty well explained. And so it was a bit more intuitive to figure out how to get here. So now that we have the log parsed, we need to send it somewhere, and that's where the exporter section comes in. Here we're using the OTel HTTP. So VictoriaMetrics supports OTel over HTTP, and so does Victorialogs. So what we're saying here is here's where logs go, here's where metrics go. And then to make sure that applications get the right stream fields in VictoriaMetrics, we're setting that header that says use the host name and the app name fields as the stream fields. When you are setting up stream fields, the recommended best practice is to use fields that would identify an individual instance of an app. So you wouldn't use something like trace ID. You would use the app name from syslog and the host name to identify that it's this application name on this host. And then while I was setting this up, I did have to set up debug mode so I can figure out where I wanted to grab or where I wanted to put the Grok filter. So that's still left in. And then the service section is where we kind of plug everything together. So everything we've done so far is just setting up all the pieces. And then in the services section, we're going to glue all this together. So the metric stuff is just saying, hey, use the batch processor on our two metric inputs and send them to OTel HTTP. Similar thing for logs, but this time, along with the batch processor, we have the transform PBS task. And then the list of extensions that come by default in OTel collector contrib. So now that we have all that set up, we can quit and we can make sure that OTel collector is happy. OTel collector contrib. And we'll see if I can type in my password, which is 12345. Mark, did we lose your audio? Or did I lose? I believe I lost my audio. 1 second. Mark, can you say words at me? Give me 1 second. Sorry about this. Um, it looks like we lost Mark. So my headset is working for now. So we are going to wait a second for Mark to come back. In the meantime, if you do have any fun logging horror stories or what your log pipeline is, feel free to put it in chat. We can discuss it right now. Another fun anecdote I have about logging is it's actually something. Looks like Mark is coming back. One anecdote I have that's actually a funny story about logging is my first date with my wife. There's actually a betting pool in the office about what I would talk about the whole time. And the bet was I would just sit there and talk about logging the entire time. The best part about that is they were right.
Hey, Matthias, can you hear me?
Yep. Yes, I can.
Yeah, okay. Chrome and StreamYard just had a fight and neither of them won.
And you lost.
Well, you all won because I disappeared for a moment. Yeah.
Yeah, I had to go for the embarrassing anecdote I've had. But while that happened, the OTel collector did restart, so we can.
So the demo gods and the Chrome memory gods struck at the same time.
Did you snap apart a stick of RAM and burn it at the altar like you were supposed to?
I did not this morning. I wanted to save it.
All right. So now we need to generate some traffic inside of Proxmox backup server. So we're going to go to admin and we are going to refresh. We don't need to upgrade prod right now. And then something else I need to double check is I believe the OTel collector was on port 8000. So we need to make sure that is also where we are sending syslog. And it's not.
That'll help.
All right. So now we're going to go to Proxmox. We are going to refresh for upgrades. Everything looks like it should be okay. And now we can go to the log explorer, go to the last 5 minutes. Here we are. So here, everything looks as it should with the message field. And now we also have all this information pulled apart into the correct area.
That sure makes grouping, searching, and identifying things a heck of a lot easier, doesn't it?
Yes.
Yeah.
So now all of this information, is that from OTel collector? Let's run this again. But now everything is pulled apart. So now if we just wanted to search for everything that fields.user did, we can add in fields.user root at PAM. And then we can see everything that happened for root. I believe. There we go. So now we can see all the tasks as well. The reason why some of the fields have fields labeled and some of them do not is because we have vector spun up as well, listening on syslog, and it labels the it labels things a little bit differently. So we can jump into that really quick. And vector.yaml. So this is the vector configuration, and we have the same kind of flow where we have sources, transforms, and sinks. Again, it's the same word for different things because getting nerds to agree is really hard.
Tabs and spaces.
All I can think about now is the arc in Silicon Valley about that.
That's where my mind was.
Where he takes 8 stairs at a time. So here's the syslog server source. Here we're using port 9000 on all interfaces. And one nice thing that Vector has is the ability to only listen for certain addresses. So that way anybody can't send syslog that you have to parse and store. And here we have the parse syslog transform. So here we're attaching the input for the syslog server to this transform. And then Vector is interesting because they have their own DSL called Vector Remap Language, or VRL, for pulling everything apart. It gives you the ability to do some really cool and powerful things. But for like a simple use case like this, where you're pulling apart JSON, it feels weird to have to like have an if statement just to pull apart JSON. So here we're saying if the app name contains Matthias. I was doing some testing earlier, and we can show what parsing JSON looks like in a little bit. Pull it apart as JSON, and then if we have PBS in the app name, we're going to pull it apart with Grok, and then we're also going to assign the fields.owner value to the infrastructure team. So that way, if we did want to do something like separate out permissions, Victorialogs and VMauth has the ability to, when given a certain credential, add certain filters to all queries. So that way only a certain user can see the correct data, which is something we're going to get into next week. Because if you haven't noticed, everything we've been doing so far has been unencrypted and unauthenticated. And kind of the story we've had for this is we had a security person tell us to log everything. And I'm guessing they would be happy about us actually logging access to our systems, but they probably wouldn't be thrilled that it's all plain text over the wire.
Make it easier. Just one place for somebody to go and compromise.
Yeah. So there was actually a funny story about that recently. My friend sent me a story about people were finding vulnerable instances of a popular data visualization tool and then using that to enumerate the environment. So instead of using like Nmap or something like that, they were popping the observability tool and then using that to figure out what targets were in the environment.
Oh my goodness. Yeah.
Which like is actually using the tool for its intended use, but it's hilarious.
Well, yeah, that's like sort of putting the blueprints to your bank out and the thieves, Ocean's 11, looking at your blueprint, right?
Yeah.
Wow.
So now that we have metadata assigned to everything and we have the fields being parsed, one interesting thing that I found with Vector is that you needed to put things into like a separate list or a separate map. You couldn't just put it into the field directly, which is why in VMUI you saw that Vector had fields.user instead of user for the query. So now we're going to attach the parse syslog input. So in Vector, you can either attach the raw source or you could attach a transform to a given output. And then we're going to use the Elasticsearch output. One of the cool things about Victorialogs is that we support a ton of different ingestion protocols. So you saw with the OTel collector, we were using OpenTelemetry. We also support the Elasticsearch ingestion API. We support the Loki ingestion API. In the first stream, we supported syslog, but here we're using Elastic. We're making sure everything's compressed. We're not performing the health check on the Elasticsearch endpoint. And then instead of using headers to route the stream fields and everything into the correct spot, we are using query parameters. So we're using the stream fields query parameter to say, hey, use host container or app name as the stream and app name as the fields. We're going to make sure we're using the timestamp of the log and not the timestamp that data was sent. So that way we have everything accurate. And then the message field is obviously going to be message.
Is there any reason anyone would want to store both the time it was created and the time it was sent? I mean, is that delta in there? Could that be useful for any sort of diagnostic purposes? Or is
yes. If you're using like Kafka or some sort of message queue, That could be useful. You could use that to detect back pressure if you didn't have the message queue instrumented separately.
Okay.
So sometimes that does happen where the database saw the metric or whatever telemetry, and then when the telemetry was actually generated. So now we're going to make sure that vector is up and running. Type in 1, 2, 3, 4, 5 again.
It's the same as my luggage.
Your back hurts if you get that reference, probably. So now we have the syslog server up on vector. We're going to go into here, and then we're going to swap out our syslog target for vector. And then we are going to system ctl restart our syslog. And then we are going to generate some more traffic inside of Proxmox, or inside of PBS, sorry. There's definitely like a Kleenex problem with that community because everybody says, oh, I run Proxmox, but they have like 3 separate products and one of them is completely unrelated to the other 2.
Yeah.
All right, so now we can go back to our log explorer. We're going to go back to the app name and the last 5 minutes, run it again. And here we see all of the fields pulled apart. And this time they have the fields array before, because instead of just adding them as attributes directly, they're adding them to the fields objects, which is something we defined ourselves. And then this one, we also found the infra team.
Perfect.
So our last collector we had was Telegraf. And Telegraf is the one that's near and dear to my heart. I've been using it for like 5 years. And the ability for Telegraf to work with VictoriaMetrics is how I actually found out about VictoriaMetrics before I even worked here. So this one, we're actually going to go into my production environment to see what that looks like. So we're going to just change the host and port number so it's pointing at Telegraf. We are going to go system ctl restart our syslog, and then I need to hop on to different box here. And the Telegraf.
7 days, 8 hours, and 54 minutes of uptime. Notable.
I don't know if I'm ever going to meet that SLA I put in my wedding vows. The budget committee doesn't give me enough hardware to meet it. So Telegraf has different names for things, but it's the same concept of we have inputs, processors, and outputs. So here we're saying open up a syslog server on port 6666 on all interfaces, and then we have a parser for message. So this is a much more accurate representation of what enterprise setup would look like, or closer to enterprise, where we have different applications getting different logs parsed to them. So here we have a known list of applications: Traffic, Grafana, Caddy, Nextcloud, and Authentic, and Falco, that all log in JSON. And instead of just telling the syslog server this, we're using a processor, so that way we still keep the message field, which is accurate. Another thing I'm excited for next stream about is we are going to try to get Alexander, our CTO, on and explain why that's a bad idea or a good idea, or what trade-offs I'm making as a result.
So we're going to make the past 3 episodes irrelevant. We're going to lay down the truth.
Yeah. And again, we're doing the same thing with log format, where we know Alert Manager and Dendrite log as log format by default. And then here we're going to get into our grok expressions. So Proxmox and PBS have their own separate grok expressions. And we're using that tag pass option to say these applications have this grok pattern attached to them. And like I alluded to earlier, here's the expression for parsing the CSV for OpenSense filter logs. I think it's the same for pfSense too.
Very human readable.
Yeah, you could totally type all that out into a query every time.
That gave me nightmares to date myself to when I was a young child and I had books and they were choose your own adventure, but with blocks of code, like pages of code you had to type in BASIC, and always knowing that I was going to miss something, some comma, some dash. That just struck fear into my childhood heart.
So instead of having the ability to like download a 20 gigabyte game in like 10 minutes, like you do now, you were the way to download the game onto the computer.
It was, yeah. I'll share those on the next Tech Talk.
And here we are adding the port and destination name as well.
Okay.
So Telegraf should already be running, and we're going to use Grafana for this because it's already there. So we can go to Explore. We're going to make sure the right data source is there. And we're going to do tags, app name, PBS. Again, because different collectors are going to pull the metadata apart differently, we're using tags.appname because that's how Telegraf labels the data. Let's go to a wider window. There we go right here. Make sure I'm zoomed in. And again, we have Telegraf organizes things into tags and fields, so everything is organized like so. The output section was using the JSON line protocol, but I think we could skip over that. It's just a few lines of TOML, and I'll make sure it's in the Git repo for that. So I think that's everything we planned on pulling apart today. Is that correct?
I believe so. I had Chrome crash on me, and I'm not trying to open another tab to look at our speaker notes on here because that could be a disaster. But yeah, I think that's what we wanted to show. And you know, what I'm continuing to find interesting in this is that it's once you understand what you need to get set up, a couple of configuration files, and it really is just so easy to get the data in. And the optimization or enrichment of the data, you can see that analyzing and reporting or just learning from this is so much easier once it's enriched.
Yeah. And here's an example of what a structured logging application would look like. So this is from Traffic Proxy. So here we're seeing all this information pulled apart. So if we wanted to see everything coming from this IP address, we could just add that right there. And everything's right there as well. Or everything's right there. We're able to see everything just from that client IP, and we didn't even have to write a query or use unpack JSON or anything like that. And then that makes our dashboards really easy as well. So if we go to the Proxmox backup server dashboard, since that's the data set we've been working with today, everything's right here. And then for the Proxmox hypervisor, we get the same, we get a really similar interface inside of our observability tool that we get inside of the application itself. So if we do get an alert from Alert Manager that points us here, it almost looks like we're looking at the task log from Proxmox itself, which is really nice. But one other feature we wanted to go over was alerting and recording rules. So let's go to, where was it? So here we have our failed sudo attempts. So are you familiar with recording rules, Mark?
No, I at a high level, but let's pretend I'm not. Wink, wink.
So recording rules is a way of running a bunch of instant queries to generate metrics. So if you have a really chunky query or a really complex query that you want to run over a long period of time, you could hit timeouts, or it could take forever for that query to respond. So what recording rules will do is run that query over a small 5-minute window. It's 5 minutes by default. You can tune it to what you need. And then it will store that as a separate time series. So then you could just pull that one metric rather than have to say, if we wanted to get the number of failed pseudo attempts over a week or something like that, we'd have to pull the entire audit log and then find the metric in that audit log and then do a count over that. Whereas if we use a recording rule, we can say, hey, run this query every couple minutes, store that as a metric, and then we just pull that metric out.
Okay, so much faster than I'm presuming.
Correct.
Yeah.
Pulling one metric is going to be much faster, or a few metrics is going to be much faster than reading all the logs from a database. Yeah. Victorialogs is fast and can do that better than other databases, but it's just like a fundamental thing that we can't change. Yeah. The laws of physics still apply.
Until Victoria Physics is released.
So here we see, I actually remember to type my password correctly most of the time. But we can also generate some traffic for that in a second. Now we're going to split. We're going to pull up the Victorialogs data source, and then we're going to look for faileds. What was that metric name? Pango log alerts, failed pseudo attempts. I always get slightly confused about like the naming convention for recording rules, but here we can see that we are able to get that to pull really fast. Whereas here, loads pretty quickly, but kind of slow, but we also have that as one metric right here too. The best use case I've had for this is DNS queries. It's always DNS for my examples and when things go wrong. So you could use a recording rule to count the number of like failed DNS queries for AdGuard or something like that. So I was testing AdGuard a little bit ago. You close that out. And then AdGuard, blocked request rates. Okay. So here we're pulling the last 30 days of data and the results show up instantaneously. Whereas if we had to pull that same information from Victorialogs, it would have taken a much longer period of time. Mm-hmm. The other nice thing too is, go ahead.
I was just going to say real quick that I know that Kuba has asked some questions in the chat. So if it's all right, we'll address those at the end of this. If that's good, Kuba, we're seeing those and looking forward to addressing it. Thanks.
Yeah. So Kuba's asked a really nice question. He's happy about running a single node of Victorialogs. The cluster version of Victorialogs should be out in like the next couple weeks or so. And you will be able to upgrade your single node to cluster. And thanks for testing out the single node version. As far as he's comparing it to his 8-node or their 8-node Elasticsearch cluster. And we've seen performance similar to like 30 to 40 node Elasticsearch clusters running on a single node of VictoriaMetrics just fine. However, there are availability issues of running everything on a single node. So in the meantime, it is possible to set 2 different sinks or write targets that are independent instances of Victorialogs, and then place a load balancer in front of the write path. So that way, if one instance goes down, you'll still be able to see data from the other instance.
Yeah. Matthias, I don't know if you know the answer to this or not, but is that sizing difference between Elasticsearch and Victorialogs, is that due to the JVM requirements and the memory, top end memory limitations for Elasticsearch nodes that require that bigger footprint? I'm just curious as to Obviously, we're smaller on disk, but it's interesting that we can be that much more efficient. I'm wondering why.
I think we should save the details of that for Alexander. I'm guessing the way we store data is more efficient, and that's a big part of it. I'm not sure how much of it is like a JVM or Java thing versus Golang thing.
Yeah,
because there are Java applications that are very cleverly written to scale out to giant systems. Kafka comes to mind for that, where the reason why it's a very performant message queue has nothing to do with the fact that it was written in Java.
Okay.
Obviously, like it would be faster than like a super slow language like Python.
Mm-hmm. Yeah, and the only reason I raised that is I remember that we used to have limitations around 64 gigs of RAM, and that's how much could be actually addressed. Anything above that actually couldn't be utilized. So the number of nodes wasn't dependent on the speed of Elastic. It was because of that limitation of RAM available to the JVM, but that may have changed. So we'll wait for Alex to address that. Good point.
Yeah. I know we can't address more than 64 gigabytes of RAM. So I've seen setups ingesting a few million messages per second on a pretty beefy single node. And that was well over 64 gigs of RAM of usage. And I've seen a couple hundred messages per second being ingested on, I believe it was like 48 cores and 96 gigs of RAM.
Yeah. Awesome.
And then if you do want to check the usage, we do include our own Victorialogs single node. We do include our own dashboard for Victorialogs. So here we can see, obviously, my lowly home lab with 7 days of uptime doesn't have quite the ingestion rate, but it's still relatively efficient. All the logs for, I believe I have like 20 VMs, somewhere around that, for a week is only 6 gigabytes of storage.
So, and as Alex had pointed out on our virtual meetup too, is the single node instance of Victorialogs. When cluster comes out, it can just become part of it. So each node is going to have different functionality. So testing with Victorialogs today and getting something implemented doesn't mean that you're not able to just go cluster when cluster is here. It just means you can get a head start on it.
Yeah, and we do have benchmarks too that compare. Alexander on the last quarterly stream compared us to ClickHouse and Elastic for analytics, but we also have a benchmark that you can run yourself that compares Victorialogs, Elasticsearch, and Loki.
Yeah,
and that's where we found that we were roughly 30x more efficient on memory than Elastic.
Yeah. Perfect. Exactly. And if anybody wants more information on that, that's also available on our YouTube channel. That's the session we had earlier this week or late last week. My memory of time is gone, but it's our most recent one. It's could be really informative.
Yeah.
Right. Sorry.
So your 8-node Elasticsearch cluster could probably be replaced by a single node of Victorialogs, and then when cluster version does come out, you could tweak that to meet your availability requirements. That's a great question. And another nice thing back to recording rules and alerting rules. If you did want to use this for some security use cases, you can also set up alerting rules using the same mechanism. So using VM alert, and you could either run a separate instance of VM alert or use VMauth to route the different types of rules to the correct data source and use one instance of VM alert. You could use that to generate alerting rules, like a human accessing production is the one I used to have set up. So that way, if you are very disciplined about infrastructure as code and only the service account should be accessing it, you could get notified when that doesn't happen. We
almost are at a point where we should be more worried about a non-human accessing that. When is an AI agent accessing this?
Performance tuning.
I'm almost at the end of my jokes. I'll be here all week. Try the veal.
So yeah, I think that's pretty much everything we had planned. I can actually go through one fun troubleshooting scenario that Fred and I went through with VM anomaly recently.
Yeah.
So we were noticing. So I do most of my testing in my home lab, and I was having issues with VM anomaly, which just announced can way to scale horizontally using a sharding approach. So VM anomaly is now smart enough to take a configuration and pull it into individual parts. And then based on a couple of variables, it knows which parts that instance of VM anomaly should be responsible for. And when we were testing it, we were running into a bunch of issues. So I was able to go here, and even though Fred doesn't have access to my Victorialogs environment, I was able to just go here, type in tags, app name, VM anomaly. And I was able to pull out everything that contained, what was that, debug and scheduler. So we'll go through this how we actually did. So we were only interested in debug logs because we were only seeing that some of the logs were being processed. So we publish our own VM anomaly dashboard. And we were noticing that only one of the configurations was, I think it was in statistics. We were only noticing that some of the, yeah, keep pulling up the wrong dashboard, self-monitoring. I switched back to a monolithic config, but we noticed that only one of the models was running. And so I was able to go into this query, pull out all the debug logs, and he's like, oh, I only need stuff with scheduler, so I can go into here. And then instead of having to have Fred squint at my screen and troubleshoot this and have him try to drive my mouse, I was able to just dump this as a JSON file, a text, or as a raw text file, and just send it over to him so he could read it and use whatever tools he has locally for further processing.
Perfect. And that's awesome. Like a real world scenario of using the tool to solve a problem. That's just,
yeah. So do you want to know what the actual issue was? So yes, because this was like a brand new feature to VM anomaly, we thought it was like some bug hidden deep in the layers of the code.
Okay.
I can't spell. That was it. So the approach that it uses, it requires you to specify how many shards of VM anomaly you're running and what shard number it is.
Okay.
And it uses, what is it, singular for members and plural for the individual member. And because I was lazy and copy pasted, I used members for both. Yep. And so it was just using the default value, which is 0. So it was only taking the 0th shard.
Those are the ones where you just go, oh, okay. Perfect. Oh, that's awesome. Well, this has been a really good session. I hope, I've certainly, again, one thing I really like about this is it's a learning experience each time for me, just to dive a bit deeper, especially when we get into what are the scenarios, like how do we not just get it running, but make it better? So I think we're now at a stage where we can start to get people hopefully excited about the next session, where, as Matthias has said, we are going to try to rope in our CTO to come in and really just talk about the future more of Victorialogs, set straight any misinformation that we may have put out or misconstrued, which I don't think we have here. But I think that's a fun one to wrap up. Our logging session is going to be the last Thursday of next month. So if there are any questions that come up, please feel free to reach out to our team directly. Again, encourage everyone to join our community Slack, super active. We've got everybody from our co-founders, core engineers, through really everybody across our organization is in there and happy to talk and help people out. We encourage you to get your hands on with Victorialogs. We'd love to get some feedback on the product, even in the next session. If anybody has any, it would be great. And any success or trouble stories, we'd love to hear those too. Anything you want to add at the end, Matthias?
I think you got everything. One thing I would mention is that if you do find any bugs, please feel free to report them in Slack or ideally on GitHub. The more context, the better. Yep.
Awesome. Encourage everyone to do that. We'd love to see more people get hands-on and get that feedback. So thank you again, Matthias. That was a super session. Thank you, everybody, for watching this live or anybody who's going to be watching it on demand at a later point. We look forward to next month's session and the continuation of sharing our tech talks. Have a great day.